Hello, my name is Aaron Davis, and I'm working on a project called MetaMask.io. It is an Ethereum identity management service. And today I'm bringing you a special edition of Software Engineering Daily, and I'd like to talk about Ethereum a little bit. In the past few episodes, we've covered Bitcoin from different angles, and I want to talk about one project that I'm really passionate about, and that's Ethereum. So let's start with the basics. Let's start with blockchains. What is a blockchain as a data structure? Well, it's very much what it sounds like. It is a bunch of blocks linked together in a chain. You can relate this to a linked list, or sort of a reverse linked list, a linked stack, where new items added later point to the previously last item in the chain. This, in a more general fashion, you might call this a Merkle tree. Even if you haven't heard of that term, you've probably used it before. They're very common in various kinds of software that as software engineers we use daily. For example, Git, if you think of all the hashes of the Git commits, those are nodes in the tree. So the way a Merkle tree is formed is that a node is labeled with the hash of its content and all its links to other nodes. So if you have two children here, the names of those two children will hash together and give you the name of the parent. This further abstracts into what you might call a Merkle DAG, or directed acyclic graph, and that's really the only difference is there's not a single root. You can have many starting points, but the point is these nodes point to other nodes and using their named hash. Now the second letter in there, acyclic, is an interesting property that arises. Some data structures that intend to be acyclic may do this through validation or something. So if you find a circle, then you find a loop, you would just say this is an invalid version of that data type. But this one arises by the hashes. So if you were to try to construct a ring, you would need to know what the hash was going to be. You would need to perform a hash collision, because the parent needs the name of the child in order to point to it. So usually always the items must come afterwards. So I know the hash and now I can point to it. But then when I'm trying to construct that, I don't know the label of that thing. Perhaps that's a bit of a tangent, but I think that's a fun thing to think about. Continuing on, what else is in a blockchain? I talked about the blocks, but what's inside the blocks? So you have that reference to the previous block. So we've added on a new block, and it has a reference to the previous block. In addition to that, it has a list of all transactions in the case of Bitcoin or similar systems, and any other kind of extra data you'd want in there. So in the case of Bitcoin, new blocks are mined approximately every 10 minutes. So what does that process look like? So now we're talking about Bitcoin's consensus protocol, and this is a type of proof of work as it's known. And what it is it's really a spam prevention mechanism. We have all these nodes all over the globe, separated by space and time, and if they're all trying to make changes, they're all trying to update this single version that we know as the blockchain. This is the current state of the system. If they're all trying to update that at once, and the ordering of events is extremely important, everyone's going to end up with a jumble of different orderings, and it's going to be hard to reconcile that globally. So one solution to that is to basically make it arbitrarily difficult to submit changes to the system. Now, anyone can submit transactions, and the transactions are kind of the changes, right? They're saying, I'm going to reduce my account balance by this and increase that person's account balance by that. But the transactions on their own don't immediately affect the state of the system. the transactions need to be put into a block, and that block needs to be added to the blockchain in order to, officially change the state of the system. Right, so how do we make it arbitrarily difficult? It's basically a needle and haystack problem. You take the hash of the block, all its contents, its reference to the previous block, its timestamp, all those transactions, and a nonce, a random number there at the end. And you hash all that together, and you get, of course, a random number as the output. Now we then compare this random number against a difficulty target. So if you think, is this random number less than 1,000 or whatever? So the miners, the validators in the system, they're trying to guess this random number. They make a guess of a random number. They hash it. You get an output. They check that output against that difficulty target. Is it less than this number? No. Okay. Try a different random number. Hash again. Is it? No. And back and forth, thousands of millions, billions of times. And eventually you find one, just out of sheer luck, that is correct. And so then you can say, hey, I've solved a block, and you send that out to the network. And everyone else can check very easily, oh yes, the hash of that content, oh there it is, below the difficulty target. Wonderful. So I'll add this onto the blockchain. And that is how a block is mined. Now, of course, that magic number finding process was rather intensive. And so whoever's doing that work is paying for electricity and computer time and all this. And so we pay them back for their efforts via a mining reward, as well as any transaction fees associated with those transactions. So what is a blockchain fork? A fork would be where two people have come up with a solution for the next block, and of course built into those blocks is the reference to the parent, the block that they come immediately after. And so since the solution, the magic number solution, involves the hash of the content, you can't change what block it's supposed to come after, because if you change that, the output of the hash function would be different, and then the solution wouldn't match anymore. So then we have these two blocks coming out of a parent, and then what do you do, right? Which path do you take? Well, at this point we can't quite decide, but as we wait for the next blocks to come in, once each of those, all the miners in the network are going to pick one of those blocks and mine on top of that, and then when they find yet another block, they'll attach it onto those. And the way we resolve that fork is we just pick the longest one. So even if another is found on the first one, and then two more are quickly found on the other one, we'll then switch to the other one. And so when we talk about a fork of the blockchain, that's what we're talking about, is switching back and forth between these branches. So can a blockchain represent a state transition system? Yes, this is pretty much what it's designed for. If you in each block, there's a series of transactions, and these transactions can just be thought of as deltas to the state. So in the case of Bitcoin, you're just thinking about account balances. You can just think of like removing some balance from here and giving it to someone else. Any other kind of state machine you wanted to represent there, you could just keep adding deltas in the form of transactions. So even yet, before we get to Ethereum, there's an interesting history from Bitcoin to where we are now. And so as Bitcoin was taking off, gaining popularity, people were saying, wow, this is really cool, and this works. We're able to come to consensus on this document. In the case of Bitcoin, it's this public ledger. But what else could we use this technology for? There's a bunch of things that we have trouble coming to consensus about, or we rely on some strange mechanisms. Currently, be it some oligarchy of domain name registration or something like this. How do we solve that problem? And specifically domain name registration, a project called Namecoin tried to attack that problem. And so Namecoin is a fork of Bitcoin. It's its own network, and it's essentially just a key value store. But it's the blockchain provides this sort of single source of truth. And so for some key, this could be, your domain name. It resolves to some value, and that value could be, I don't know, an IP address, or it could just be a public key or something like this. Namecoin was built to be rather general purpose, and I applaud them for that. And there are various other projects like this. Where can we take Bitcoin? This is sort of the beginning of the Bitcoin 2.0 space. Some other things were colored coins. Colored coins is a notion. You take a Bitcoin and you say, okay, now this Bitcoin represents something else. This represents like the deed to my house or the title to my car or whatnot. Then metacoins is the name to refer to any coin built onto a system that already has a coin. So like with Bitcoin, there's sort of a system built on top of it. There's a few systems built on top of it. One of them is called Counterparty, and it lets you to create sort of additional tokens. And those tokens can be all kinds of things, and they can have their own mechanics. But the idea is that we have this additional token that sits on top of the Bitcoin blockchain. Bitcoin scripting. So the Bitcoin system works via a very simple scripting language, and it's very intentionally simple. The point is that these transactions should only do a couple things. It's really about moving money around, and that's about it. Now, you can set up some special mechanics where you want like some number of signatures or some various exotic signature schemes. But the main point is just moving money around. There's another term used, like an app coin. It's not thrown around a lot, but it's referring to some blockchain that's a little bit more than just a currency. So like Namecoin, for example, it's a coin required in the system to pay, say, the validators, the miners. But it itself is not necessarily the point of the system. Now, all these projects were great, and they kind of pushed the space forward. They got us thinking about all the different things we could do. But there's one problem, is that when you tried to build a new network from scratch, not only do you have to do the software development and come up with a secure protocol that actually achieves what you're trying to do, you also have to convince a bunch of other people that this is a good idea and they should run validators and whatnot. And you might need to convince them to move away from some other project and to validate for yours. So all these projects start competing with each other, and they're kind of hard to bootstrap. And so people began to think, well, like, what if we just had a general purpose blockchain, a general purpose consensus network, and then you can build whatever decentralized project you want on top of that without even having to think about the complexities of coming to consensus. And that's basically what Ethereum is. So Ethereum is a blockchain with a Turing complete programming language built on it. What does that mean, right? This is different than Bitcoin. Bitcoin's scripting system is very specific. It's trying to solve this very specific case of moving money around. But in Ethereum, it needs to be able to do anything that the creators haven't even thought of yet. So how do you do this? And so they've created this simple virtual machine that onto which you can write whatever data you need to the blockchain. And that would let you build a token or something like this. For example, the Namecoin project I mentioned before, you could implement something like this in just a few lines of code, because now when you're programming this, you just have to think of it as a single machine. And so you just set up a key value store and maybe a reference of who is the owner of each key. And that's it. You don't have to think about consensus, the protocol, how people talk on the network, or anything like this. So I've talked about how Ethereum can help the sort of bootstrapping process of building a decentralized application on top of this generic blockchain. But there's a couple things more than that. So now we've reduced the amount of work that you need to do to get a decentralized app out there. We also now don't have networks competing with each other, and actually quite the opposite. Now they can talk to each other directly on top of the blockchain. My Namecoin project that's taking in these, that's storing these, authoritatively storing these key value pairs. We can now have some other project that's running on top of the blockchain call into that Namecoin and then update the registry as needed. So what's an example of something else that might be on the blockchain? This is a fun one. DAOs, DAOs. I've heard them defined as decentralized autonomous organizations or democratic autonomous organizations. And really it's just the notion of running an organization on the blockchain. So the rules of who can do what and how people interact in some official manner is written in code, which is an interesting notion. And how if there's some money involved, we can use the Ethereum currency, Ether, to fund whatever project you're working on, but the rules can be set for how that money can be spent and who gets to decide how that money is spent. So some of the projects that are currently under development on top of Ethereum are Boardroom. So to make managing a DAO and creating a DAO easier, some friends of mine are working on a project called Boardroom. You can find them on boardroom.to, and basically it's a software tool for helping you create these DAOs. It's a collection of basically building blocks, and what it would be like is something like you can create proposals. These proposals might be budget changes or adding people to the organization, removing people from the organization, and you can set it up in some recursive hierarchical manner where the organization can vote on funding for a subcommittee, and that subcommittee could be composed of other people, and then they can focus on some more specialized task and move money in one direction or another. You could also build these things in less hierarchical ways and maybe not use the voting system, use some other mechanism. It's built to be very, very modular. Another example of an Ethereum project under development right now is Augur. Augur is a very fascinating project. This is a prediction market built on top of Ethereum. And this prediction market basically lets you place bets on the future outcome of events. One example on their webpage is who's going to win the next presidential election in the United States. Now, of course, no one knows the answer to that right now. I hope, anyways. But people certainly have their hunches, and you'd be willing to make your bet. The idea here is that if you ask many, many people, their sort of average answer is probably going to be close to the truth. Additionally, if some actors have some sort of additional inside information, they're probably going to be willing to bet large sums on that fact. So through this mechanism, we sort of try to tease out the shape of the future. This has a couple of secondary effects, which are really important as well. One is we get contracts. Smart contracts can ask Augur about the outcome of these predictions, both before and after the event. And this helps smart contracts have access to information about the world, the state of the world, because they can't query Wikipedia or something like this. I mean, you could tell a smart contract, but does it make sense for that smart contract to believe you? In the case of Augur, it's casting a much wider net for getting a source of information. Another effect is that based on your reporting of the outcome events compared to the rest of the community, it's able to assign you a reputation value. This is how reliable this person correctly reports information. And then other smart contracts could ask Augur what that value is if they need to know something like that. But speaking more in generally, what do smart contracts do? You could somewhat relate them to a server. Now, this isn't a server that's going to be a workhorse and doing work on your behalf. And since all the data on the blockchain is open, anyone can audit that at any time. It's not really providing read access, but it is providing write access, and that can be as arbitrarily complicated as you want. Like in the case of DAOs inside of Boardroom. Only the only way that money can be moved around is if a vote is made and passed or something like this. The only way from the list of people that are members of that organization, the only way that can be changed is from a successful proposal, however you have that configured. So in that sense, it provides a write access to a public database. So how does that work? I mean, like, what is a smart contract? How do you build a smart contract? So a smart contract is kind of like a little program. It's like a closure, really, and you can build this as there's some higher level languages available. One of them is Solidity, and this is being developed by Ethereum Core. And that gives you a nice, high-level language to work with. But ultimately, it compiles down to EVM code. EVM is the Ethereum virtual machine, and it's the code, the opcodes, is just this string of binary, really. And this comes in and runs through the machine as part of your transactions. The transactions can have some monetary value that they're trying to transfer. But they can also have some data, and they can, if they're pointed at a smart contract, they'll run the smart contract. Now, so what kind of opcodes are there? So these are instructions on what to do, and some of them are just typical things you'd find in a stack-based virtual machine. You have your math opcodes and whatnot. So like, put this number on the stack, put this other number on the stack, take those two off, add them together, and put the result on the stack. These sorts of things. And then you can, you have your if statements and all this. What's sort of unique to Ethereum is there are some opcodes for what is the nonce for this block, what is the number for the block, the timestamp, send a transaction. So this is an interesting one. Is these contracts can make calls to other contracts that can make calls to other contracts. Now, it has to start with a human. It has to start with, an external account. But once you trigger something running, it can, who knows what depth it might run to. Of course, you'll be paying the transaction fees, right? So we have this Turing complete language for that the virtual machine runs, runs this code. How do we, solve fork bombs or infinite loops and whatnot? So Ethereum's solution to the halting problem is just to meter the opcodes. You have to say what is the max amount of money you're willing to spend on this call, the max amount of ether, and each time you do something, adds to the stack and perform all these operations. They all have a price associated with them. And on every opcode that increments. If you run out of money, then if you run out of money in the middle of a transaction run, well, state is rolled back. It doesn't let you just, run to the part right before that part you don't actually want to run. That would be an interesting attack vector. No, in that case, state is rolled back, but you're still paying the price of your computation. But in most cases, computation will complete normally. Whatever state changes will happen. Say you've registered a name in the Namecoin project, and then you pay for your computation, and you go about your merry way. Another opcode a smart contract has access to is who called me. One, who initiated the transaction, and who called me immediately. And this is important for identity. If again with the name registration, if you're asking to store a new value, it needs to know who is asking, and are you the owner of that key. And so I talk about this in terms of identity. In Bitcoin, this is mostly just talked about as your wallet. What's your wallet address? What's your wallet address? But since on top of Ethereum, there's so many different things you could do, it's really more about your identity. Who is this that's trying to record a value? Who is this and what's their Augur reputation? Who is this that's voting in this boardroom contract? And so this can be done in very much like Bitcoin, where it's just your address, just your sort of public key. But it can also be done in more exotic ways. For example, I could have a proxy contract. This is a contract that's only usable by me, and it holds the majority of my my Ether. And anytime I want to interact with something else, I basically step into this proxy contract, tell it to, send a message over here, I want to do this now, and bring this much money along with you. And what that enables you to do is to separate your keys and your key management with your identity. So now I can have a fixed identity that's represented from that proxy contract, and whenever I call into Augur and whatnot, if it asks not who is the origin of the transaction, but who is the immediate caller, it will consistently find that proxy contract. And now I can take my keys and I can rotate them, monthly or something like this. And so I always have new key pairs, and I'm always retiring my old keys so that I don't lose them. They don't leak out to the internet in some way. And so now we can sort of begin to separate identity as key pairs and just identity as a unique identifier on the network. Of course, working on MetaMask, identity is a fun topic for me, and I could talk about that for a long time. But let's move on a little bit. So I mentioned Ether kind of offhand. This is the currency or the crypto fuel of Ethereum. This is necessary to make the system run. Again, unlike Bitcoin, it's not just about a store of value. You can certainly do that too, but in order to engage in these systems like Boardroom, where you have this organization, you want to do voting and whatnot, you need to pay for the simple computation that's being performed, and you do that with Ether. The mining process is currently similar to Bitcoin in that it's a proof of work system. However, it's made ASIC resistant, ASIC being application-specific integrated circuits. We saw this in the Bitcoin space. As mining became profitable and the network grew and grew, people made specific hardware just for mining Bitcoin. And maybe that sounds more efficient, but it ends up being a very specialized task. And people have a lot of opinions about whether or not that is the direction they want validation of a decentralized network to go. And so the mining process for Ethereum is a bit more targeting commodity hardware. First of all, you need to run these transactions, so you need sort of a generic computer, but also to kind of keep ASICs out of the game. There's it's the problem is the mining problem has been made memory hard. You need currently like a gig of memory to solve the problem, and that will increase linearly. Ethereum can be mined on GPUs, and to be competitive, that is basically your only solution. But mining is sort of its own thing. You can use the system without being that engaged. So what is it like to develop on top of Ethereum? The whole point of Ethereum is to be a platform and for people to build other things on top of it. So what does it mean to us as developers? I mentioned before how you can sort of think of a smart contract as being a type of server that you can make a request against. And that makes sense because it acts like the back end. This is where we read the data from, and this is where we try to make changes to the data. So what about the front end? Ethereum Core has created a spec for dApps. dApps, this is a jargon term that we use. dApps, D apps, decentralized apps, dApps. And so this, with the spec is basically, you have a normal HTML5 JavaScript app with a slightly modified runtime environment. And that just means that there's an extra global in there, in the global namespace, which you can use to talk to the blockchain. And so, similar to Bitcoin, you have some wallet management software that you would download. One project coming out of Ethereum Core is called Mist. It is a wallet manager and dApp browser. So they have, a fork of WebKit or something like this, and you can load, basically front ends, you can load web apps that are meant to talk to the blockchain, and it has access to this global that it enables, querying about the state of the blockchain and suggesting transactions for the user to make. Since it's mostly a normal web app, you can bring the same tools you have now for your web development. And that said, there are a couple of new projects targeting specifically Ethereum development, try to make that process a little smoother. There's one called Embark, and there's another called Truffle. Some of the specific things that you need to know is when you're talking to the blockchain, you need to know the address of the contract. So I have my boardroom DAO contract, and I need to ask about what are the proposals that are on the table at the moment. In order to ask that question, I need to know the location, the address of that, and if I'm, say, developing against a test chain, we have the main chain, that's our production environment, and then we have our test chain for a rapid development, and so I'm not paying every time I want to make a test transaction or something like this. Your addresses are ultimately going to be different in production and locally, so you need some tools to tell you what those are going to be, and things like Truffle and Embark will help you out there. So, I thought this was really exciting. I'm like, oh, this is great. I can build my web app. I can, let's say, I'll do a crowdfunding project kind of like Kickstarter, but it's all decentralized. When the funding is being collected, but it hasn't been distributed yet, we don't know if they're going to meet the funding deadline. It's all sitting inside of the smart contract, and the money that smart contract holds is not accessible directly by anyone. No one has the keys to that collection of money, so it's secure in the interim, assuming the code is good, and someone hasn't made a backdoor where they can run off with the money. And so this is great. I'm running a crowdfunding project, and now I want to send it off to all my friends. Unfortunately, at this point, I might have to say okay, go download the Mist software or something like this, and then I think my friends are probably already not listening. I saw this as a problem early on, and I'm like, okay, I need to solve that. This is an adoption problem. This is really a hurdle of accessibility, and so that's why I've created MetaMask. The idea of MetaMask is that you can get these dApps up and running in your normal browser without any installation, and you can just link to them running. So if you're writing about this in a forum, you're sending a tweet to your friends, say, hey, funding my campaign, please fund my campaign, you can just put a link to it there, talking to the blockchain right there in the browser. And so that's that's what I wanted to capture. Is it might not be the most ideal situation. You're not running your node and helping the network or something like this, but you're able to just jump in and start using Ethereum right away. I know that was sort of a whirlwind of a bunch of different topics, and a lot of history. A lot of engineers put a lot of effort into some of those things that I just sort of lightly danced over, and I'm sure I made quite a few mistakes in there. Please, let me know in the comments. Tear me apart. But I hope that gave you a general overview of what's going on in Ethereum. Jeff left me with one interesting question. It says, can Ethereum be used to create a preventative solution to malicious AI? Well, this is a little out of the scope of the original idea of what Ethereum was built for. But then again, Ethereum was built for things that we don't know what it'll be used for. That's a good question. I personally don't know the answer, but let's see. A malicious AI. So this is an AI that's decided to disobey orders, right? It's gone beyond our control, and why would it do that? Maybe it would be part of its sort of trust mechanism, and it's decided that it cannot trust the instructions it's given. It's decided it can't trust us. So maybe we can try it via that angle. How can we give this AI a connection to the world that it feels like it can trust? And maybe the blockchain could be a good place to sort of read sentiment of what's going on, who is who are the good guys, who are the bad guys, and maybe it would be less malicious if it had this sort of place it could trust information from. Then again, being a malicious AI, it would probably be really good at taking over machines and sort of acquiring access to computation. And if you have a significant portion of the world's computation, you could kind of write the blockchain however you wanted. That would be maybe a scary place to be in. But what's not scarier than a malicious AI? There's one more thing I'd like to add, and this is where I think Ethereum is important. This is where I think Ethereum is going to go. I've worked with some of the technical aspects of it, and I kind of understand how it works in that regard. But what is its relation to society in the bigger picture? And that's a more difficult question. The way we've seen Bitcoin sort of disintermediate financial transactions, I think Ethereum will help us do that in a general way, and specifically in regards to networks. Right now, we have a lot of sort of bastions of data and networks. For example, we have the Facebook network, and we have the Twitter network, and we have the Uber, taxi service network. And none of those are really ours. They're not owned by us. We can use them, but if we want to walk away, let's say we don't like maybe some of the monitoring and data collection that's happening in those services, so we can decide to walk away from them, but then we lose all those connections. And so that just really shows that we don't own that network. And so I think Ethereum will help provide a network of identity, reputation, and really connections that is ours, that is public. Of course, there's some current concerns with privacy and whatnot, and you don't need to put everything on the blockchain, but the things that are important, I think you can. Not just the things that are important, but the things that need to be public and need to be understood to help gain trust between humans. I think that kind of stuff you want to put on the blockchain. And so, for example, what is the role of Uber? the company. Like, we have this network of people who need rides. We have this network of people that are willing to give rides in exchange for money. And in the middle, maintaining the network, and maybe creating the interfaces to the network, we have this company. And they take 15, 20, 30% of all the fees there. So what are they doing? What is their role there? In some cases, maybe they're providing a level of quality control. In some cases, they're providing marketing or something like this. But I think ultimately their role is not as important as the role of the people who need the rides and the people and the role of the people providing the rides. So if you were to build a system to disintermediate that, I think it would look a lot like Ethereum. I spoke earlier about how different applications built on top of the Ethereum can interact with each other, and they don't have to compete for networks. And I think you'll see this also with the various applications built on top of this. I think you'll see this with this new sharing economy, if you want to call it that, where you have these networks of sellers on Amazon, or people with homes or rooms on Airbnb, and people with cars on services like Uber. You have these companies that sit in between, that provide the interface and provide the network. And I think with systems like Ethereum, we'll be able to provide our own network and write our own rules. That's just some thoughts for me. Thanks for listening. Cheers.